Yes. I hope everyone has joined. So let's start. So computer vision is the name of the course. So in this first lecture, I will talk about computer vision in general and what will be there in the course. Can someone confirm that I can be very well heard? Can someone type a message? We hear your voice. There's a low sound.
Yes, sir, we can clear you.
I can be heard, right? Okay. Yes. Thank you very much. Yes. If I cannot be heard, please don't hesitate to uh, type a message or you can turn on the mic and talk. Yeah. You're most welcome to do that. Okay. So computer vision is the topic. So we will slowly go through the slides. So uh, I'm from the electronics department, as you know. So I graduated in 2001 from the electronics department at Morato University. Then after that, I studied at Western University in Canada for 5 years. So during these days, now this is just after the winter. Maybe during February, the university looks like this. Here's an actual picture of that university. It's beautiful, snow covered. So there also I studied the computer vision. Um, so I have quite a bit of experience in this area. Okay, so in this course, we will start with the first image processing and then look at early computer vision. So how to sample images, how to interpolate them, so-called point operations, so-called spatial filtering, edge detection, feature extraction, optic flows. These simple operations will be studied early in the course. Then after that, we will look at slightly high level ones called fitting and alignment. And we will see how to fit lines to a set of points, which you may have studied under regression. Then voting methods like ransack and how to do transformations and how to stitch a couple of images together. Then we will look at how images are formed based on the perspective projection, studying about cameras, light, shading, and a little bit about color. Then we'll be ready to study 3D vision. That means using multiple images, for example, using two-wave geometry and so on, how to make a 3D reconstruction. And then we will look at some modern 3D reconstruction methods also. Then as the fifth topic, we will look at segmentation. Segmentation means extracting something out of an image. Maybe you want to extract a flower out of that image and put in a different background. So those kind of things are called segmentation. We will study that. And then we will introduce the deep learning for vision. And this will be a large part of the course where we study the convolutional neural networks and some transformers that carry out bulk of the vision work in the industry and in research. Then we look at how object detection happens, and specifically, we will understand how the classic or slightly old RCNN line of object detectors work, and then how YOLO-like object detectors work, which you may have used already. Then we look at some recent topics, given the availability of time, a little bit of vision transformers, foundation models, clips, SAM, vision language models, generative models, and if possible, diffusion, and so on. All these things will, the final things will depend on the time that we have and the enthusiasm you have to learn this thing. Yeah. Briefly about the assessment, so there will be in-class, this totals the continuous assessments. There will be in-class quizzes. They are very simple quizzes. So today also there will be a quiz. If you listen to the lecture, you can get 100% out of that. In regard to the quiz, I will take best 8 out of 10. That means you can miss couple of quizzes because I understand that you cannot do all the quizzes. Sometimes you have to attend to some other work also. Then there will be 3 assignments. There are marks assigned for these assignments, but I do not know how valuable these assignments will be because all these can be solved using ChatGPT and so on. Then finally, open book, open internet examination. So remember that open internet and open book does not mean that you can just look at the internet and answer. The questions will be formed such that you will need the knowledge to answer. Yes. Yeah. So any questions about the structure of the course or the assessment plan. Please don't hesitate to ask questions. So you have spent money on this degree program, and I have been asked to do that, and I am paid for the lecture that I do. So therefore, I am ready to answer any question that you have about this. Okay. There's a paper 2 hours, 3 hours because we had 2 hour papers. So it has to be 3 hours because computer vision papers cannot be answered in 2 hours because they are based on a little bit of application oriented questions. So that's the reason for the 3 hour exam. Thank you for that. I think it will be helpful to you, the long exams.
Excuse me, sir.
Yeah. Thank you very much for that question. Okay.
Excuse me, sir.
Yes, please.
Yeah, so, sir, regarding the fifth row, it means open internet means what actually we can use Google or any AI tools, no, right?
If you use AI tools, you will get wrong answers. That I will ensure that happens.
Okay. Right.
Yes. So
Okay,
yeah,
thanks.
hopefully I'll be able to make questions like that. Because the reason is this. Now I have a lot of lecture notes, right? Or a lot of slides are there, and you cannot possibly print those slides. On the other hand, if I put a rule saying closed internet, someone may use internet and maybe he or she will have a undue advantage over the others, right? So therefore, it's open. So therefore, there is no problem. So yeah, yes. The
Okay,
questions
thanks, sir.
the ChatGPT will not be able to answer some of the questions. Yeah, at least some. So therefore, I will know how to rank people with those questions. Yeah. Okay. Thank you for that. Okay, so we'll briefly start with the contents of the course, what would happen, and then I will briefly talk about the current AI and all these things and so on. One more question. Does the class quizzes are pre-informed? Suddenly give so every day there'll be a quiz. Yeah, they are pre-informed, but there'll be a quiz every day. Yes. So today also there'll be a quiz. Yes. But they are very easy quizzes. Don't think that the exam questions will be like quizzes. Quizzes are very easy. Yes. Okay. Yeah. Any other question? Does the quizzes compulsory? No, all the quizzes are not compulsory. As I showed you, best I will get best 8 out of 10. If I give 10 quizzes, I'll get best 80. If I give 14, you know how it will be ratioed, right? Best 11 out of 14, something like that. Not compulsory. Okay. Maybe I will show that Moodle page so that you know. Where is the Moodle page? Biggest problem is the sudden power cuts on Sundays. If any one of you like me to have the class in person, I'll be more than happy and I will come to the university and do the class. So please let me know. Maybe I will create a WhatsApp group and so therefore, see, I have a quiz for today. So there it's very easy. So you have to so two people have attempted. That means they can answer the quiz even without listening to the lecture. This is the first lecture. So please do that quiz. Okay. Yes. Any other questions? Okay. Thank you. So see.
Excuse me, sir.
Yes.
Sir, is there a reference book for this one?
I could not fully hear. Is there any?
Reference book?
Reference books, yeah. All those I will show. They are in the slides. I will show those. Um, Actually, reference books are for more knowledge. I will be covering everything in the class. If you need more knowledge and you are very enthusiastic about this, you can look at the books also. They are also very good books, and most of them are free books. Free books written by very well-known people in the field. Yes. So if someone has a question, please ask like that. I very much appreciate that. But until then, I will continue to talk about these things. Um, no more questions. Are all selected quizzes and assignment takes into CA marks? Yes, yes. Quiz marks, the best 8 will go into the CA marks. What is the weight for the end exam? That I do not know fully. I will find out from the IT faculty who designed this format and let you know. Maybe I'll let you know WhatsApp. I will create a WhatsApp group. I'll give a very short break and in that, and I will send you the link so that you can join, so I can quickly inform about it. Yes. Okay. Any other questions? Okay, so don't hesitate to ask any question at any time. Uh, in image processing and early vision, we will cover sampling. For example, if you downsample too much, you will not be able to see an image. And how do you zoom an image by interpolation? Fourier analysis, I will maybe briefly talk about it, but I don't think I will spend too much time on Fourier analysis. Then we will look at linear filtering. For example, you can see the image of the giraffe and then so-called a filter kernel. And when you run this, you can perhaps detect edges. So how to do that, we will study. And particularly edge detection, we're going to study that. And then after those early vision, once we will look at feature extraction, how to detect corners, how to detect these kind of blobs, and so on in images. So all these things will be done in Python. Learning Python is for you to do. But I will provide you links and resources if you do not know Python. But I'm sure since you know, most of you know Python. Uh, then we will look at briefly optical flow. Hopefully, I'll have time to look at that. That means how pixels move in an image, when in a video between two images. Yeah. And then we will go to the fitting and alignment. There you can see some edges have been detected here, but there is no line that has been fitted. But in this image, they are fitting a line. So with that, you will be able to give y equals mx plus c, something like that, some equation you can find. And how to do that is the topic of this. And we can do that with least squares and other voting methods like ransack and half lines. So we study that. And then alignment and image stitching. For example, you can see there is a billboard kind of a thing here. It's not an actual billboard, so it has been artificially put. Maybe on cricket grounds also, you can see that there are popping up advertisements. So how such a thing can be done will be the next topic. So this is image stitching by detecting corners and so on. And then after that, we will look at how images are formed, perspective projection. I think you may have seen that the lines seem to meet when you have parallel lines on a flow or something. So this is due to the perspective nature of that image, and we will see how to mathematically express that. And we'll briefly look at the cameras. I do not have too much knowledge about the cameras, but we'll study a little bit of light and shade, a little bit of color. I will study. Then we will go to 3D vision. So for that 3D vision, there's something called camera calibration. That means by looking at a scene and updating the parameters of the camera. That's camera calibration. And we will study that. We will know how to use code to calibrate a camera. And then how two waves are related to each other. You can see these are two waves of the same ways, and how these matching points are related. They are on the corresponding epipolar line pairs. So we will study those things. If you have time, we will do a little bit of stereo. Then these are newer methods of 3D reconstruction called NERF, Neural Radiance Space. It's a 2020 work. And then this is the one of the most new. This is the best paper award at CVPR 2025. I will talk about these conferences later. And they are able to obtain so many things like depth, feature matching, and all these things in their work. It's an excellent piece of work. So then we will briefly study about segmentation. Segmentation means if you are given an image, how to label each region by one single label. In a binary segmentation case, you can see the foreground has been assigned white and the background has been assigned black. So in this image, right-hand side image specifically, you can see it is from the so-called SAM2 by Facebook. So how they have been able to segment the football and so on in a video. So these are very advanced pieces of work. Yeah, SAM2 segment anything. So all these things came into being after this 2012 revolution by this very special paper published by Alex Krzyzewski called AlexNet. This is called AlexNet. Mm, but earlier work has been there. For example, in 1998, those days, Professor Jan Likun at New York University was working on this, and this is the network that he designed called Lenet 5 to detect digits in checks, handwritten checks. So, 2012 was a revolution where there was this thing called ImageNet Large Scale Visual Recognition Challenge. It's a challenge for which the computation people submitted entries, and then they were able to surpass that by about maybe 15 points. So people took serious notice of these so-called convolution neural networks. This is an actual picture from the AlexNet paper. So they had the two GPUs, graphics processing units. On those they ran this, and they were able to get this. So as you know, this is the hottest area in the world right now. So if you study this, it will be very good. So perhaps you know that Turing Prize. Turing Prize was in 2019. Turing Prize was won by these three people: Yoshua Bengio, Jeffrey Hinton, and Jan LeCun. So that paper we looked at, Lenet 5 was by Professor Jan LeCun. This is Jeffrey Hinton. He's the last author or the professor in the AlexNet paper. And you know that last year, or so 2024, he won the Nobel Prize for physics, but for the work that he did, pioneering work that he did in deep learning. So these authors, the AlexNet authors, I'll show their pictures also. AlexNet authors. You can see these are the AlexNet authors. You can see this is Alex Pisevsky. This is Ilya Sutskever. This is Jeffrey Hinton. Ilya Sutskever, as you know, he's the brain behind OpenAI. OpenAI's most influential papers have been last authored by him. So you can see he's an author in the AlexNet paper also. So this revolution came because of the next revolution in 2022, the ChatGPT revolution, as you know, became because of Alex Krzyzewski. Sam Altman is the CEO, but Alex Krzyzewski is the total brain behind that, I think. Okay, so we can study all these things depending on the enthusiasm that you showed. So this one is called the ResNet. Kaiming here, he was at Microsoft at that time. He was able to deepen the networks. That's his contribution. We studied that also. And then in 2017, a revolution happened called transformers. This by Ashish Vaswani and others at Google. They came up with this technique called transformers that can have so-called attention based networks. So depending on the time, we will look at that work also. Um, so in regard to using these deep learning techniques for vision, first we will study this about object detection. This is picture from the faster RCNN. These are object detection networks. Then in 2016 we had YOLO coming, Redmond and others. And YOLO has so many versions. I think up to YOLO 3, these original authors were there. Then after that, some companies took over doing YOLO kind of work, and now you have YOLO 2026 and so on. Versions are there. So we will be able to study the early versions of YOLO in this class, and then you will get some insights of how to study the latter versions of YOLO. Then in 2021, Dosovitsky and others were able to apply these so-called transformer techniques, these techniques in computer vision. This is called an image is worth 16 by 16 words. So using these small 16 by 16 patches, this is called VIT, and it's extensively used right now. So we can briefly study about that also. Then 2022, image generation revolution happened. Now you can see so many images can be generated, and this was done by a company called Stable Diffusion. So therefore, this network is called the stable diffusion paper. So you can get the semantic map, text, or other things, and based on them, they can generate images by using a process called latent diffusion. So this is slightly an advanced topic, not does not belong in this course, but if we have time, I can briefly include that. Yeah. So today we will look at the image processing and computer vision. As we did, okay, we are done with that, and now and we will look at introduction to AI, ML, deep learning, AI, and where these things fit. So what is machine learning? What neural networks are? What are attentions? What is attention used in transformers? We will briefly look at those things. And I briefly talk about what generative AI means and show some of the projects that we have done at the department. Yeah, okay. So first of all, what is image processing? In image processing, you input an image, the output is also an image. Input is an image, the output is a modified image. For example, this image, it's a beautiful image, has some noise, and you process that and get a noise-less image. I mean, less noise image, not noiseless, less noise image. And this is corrupted with some kind of noise called salt and pepper noise, and you process that and get a cleaner image. So this is, you can see input is an image, output is an image. Then we call it image processing. In digital image processing, we manipulate a digital image to produce another digital image. Yeah. So blurring, noise filtering, color enhancement. Some people call segmentation also image processing, but I think it's slightly advanced than that. Okay. So if you think about computer vision, there you get images, video, or text, and you give a decision, a new image or a new video. Yeah, you can see the difference between those two. For example, in this one, these pictures are from this famous Mars car CNN paper. That's a 2017 paper. It's a best paper award. You can see the individual peoples have been colored with individual colors. So you can see it is a decision. It decides that there is a separate person in this area of the image, not an output, not an image. So elephants and two people and so on. And here a face detection example. There's a face here, there's a face here, there's a face here. That's also a decision, right? So you can see when we put images, videos, or text, if you get a decision, that we call computer vision. So although we say text, only text is not input, text and a video, text and an image is input. Okay, so this is a generation example. I used Google Whisk for that. So I typed a prompt, so that is you can see text, generate an image of a beautiful and serene scene of a young woman asking for a young man. Yeah, so that's a beautiful image. It's a generated image. It's image generation is extremely advanced now. So examples are face detection, object detection, semantic segmentation. All these things are examples of computer vision. Okay, now let's study what these terms actually mean. What is AI? What is machine learning? What is neural networks? What is deep learning and generative AI? So these are my definitions, but they are generally well accepted definitions. So deep learning is a machine learning advancement that allows the system to automatically discover and learn representations. That's why it's called representation learning, using a stack of multiple deep layers or neurons, which is called a neural network using data. Okay, so we will study that little by little, that statement. So first of all, you have at the outer circle, the AI circle. So this one is artificial intelligence. Artificial intelligence is getting machines to behave like human beings. This is a very hard target. It has not been fully achieved yet. Within that artificial intelligence, you have machine learning. Machine learning is trying to do that with experience or data. When data is involved, we call it machine learning. So one of the machine learning techniques is neural networks, where we think that human brain also works like that by having multiple connections to this input data and trying to produce an output with that. We will look at one of those networks later today. That's neural networks. But when you have more than 8 layers of those so-called perceptrons, more than 8 layers, then we call it deep learning because AlexNet had 8 layers. So 8 or more layers, we will call it deep learning. And then generative AI means, I will describe that later. You try to mimic the probability density function of the underlying data. Um, so in all these things, you can see we try to represent an actual entity in the world using a set of numbers. That's called representation learning. For example, you give an image, you want to represent that using a vector containing 1024 numbers. You give a text, some sentence, you want to represent that using a set of numbers. So this is the thing called representation learning. So second most highly ranked machine learning conference in the world is International Conference of Learning Representations. So you can see those are the correct names that these people have used for these conferences. Yes. So now I hope you understand this definition. Deep learning is a machine learning advancement. That means it learns from data that allows a system to automatically discover or learn representations. That means it learns to represent entities in the world with numbers. Representation learning using a stack of multiple deep layers of or neurons, uh, which you call neural network, using data. So I hope that definition is clear. Okay. So if you have any question, you don't hesitate to ask at any time. Before this neural networks came into the picture, what people did was people extracted features by hand. So they detected edges, maybe they detected gradients, and they extracted features. And then they had something called a classifier that will classify between cats and dogs, for example. So maybe two labels. It's called binary classification. So one label can be cat, one label can be dog, right? So if you give a cat and it says a cat, it's good. If you give a dog image and if it says a dog, it's okay. If you give a dog image and it says cat, that's an error, right? So you can see how the loss comes into the being. So when the loss is there, what you do is using that loss, we adjust the parameters of the classifier so that it makes the correct prediction next time. Yes, so that's the classical paradigm of representation learning. So here you had that representation that you wanted to learn, the set of numbers. But now in the deep learning era, both these things have been combined. Now you can see this part and this part both are in the same neural network. They can be either convolutional neural networks, CNNs, or transformers. So, based on the loss, you modify the parameters of the whole network. So, therefore, the feature extraction as well as classification are modified, and the feature extraction is very suitable for the classification work that you do there. So, this is a advanced and more um, accurate paradigm that gives more accurate results. Okay. So, if you have a question about this, you don't hesitate to ask. I'll be very happy to answer. Yeah. Okay. Okay, now let's move on. So then why now? So what is this hype for uh, AI, deep learning, and computer vision now? Because the research directly translates to industry. People realize that using research you can start making money. So therefore they invested a lot in these areas, and then the computational hardware became available. Maybe you have an Intel i7 processor. Now there are new processors also in Intel also, and those processes are very good at desktop work, but they are not that parallel. The parallelism is less, although they can run multiple threads. They can run 24 threads at the same time, but still that parallelism is not enough. But if you take a graphics card that processes graphics and shows things on the computer screen, they can do highly parallel small computations. For example, the card that I have shown here, NVIDIA RTX 5090, is a new graphics card for gaming. It's an advanced card. They are used for gaming. They are not professional deep learning computing cards, but they are very good to do deep learning computations. Then uh, you have advanced cards. For example, NVIDIA B200, these are very, very expensive cards. I think they are more expensive than a BMW car, each card. But these large companies, they buy these cards in numbers. For example, I heard that OpenAI is purchasing 10,000 of those advanced cards. Um, they are very fast and they have a lot of memory, video memory, we call VRAM, video memory. So that large networks or large set of tensors, so-called tensors, can fit in those. So that's one reason for this deep learning advancement. The second reason, computational power becoming available. And also, the software frameworks became available. TensorFlow by Google and PyTorch by Facebook. So we will be using PyTorch in this course because all the researchers now use PyTorch. And JAX is also there. I don't know too much about JAX. And also there are ways to represent these networks in to be hardware friendly. We will not study those things in this course. I do not know also. And therefore, you can run some of these things in hardware. Usually, those hardware should also contain a graphics card. So right now, as you know, NVIDIA is the most valuable company in the world because all the deep learning computations happen in NVIDIA cards. So success stories of this, for example, self-driving. Waymo is like in the Google's company that does self-driving, and Tesla. You have seen Teslas in Sri Lanka also. They can do self-driving. And ChatGPT, you every day use Google Gemini and so on, and large-scale face detection and recognition. And then you have in phones Apple Siri and Android also. Samsung also has something. And then for coding, you use Copilot and different coding LLMs, large language models can be used. And for Amazon and so on, for personalization, they those networks can be used. For example, they exactly know what we want to buy from our profile and the past history we have with them. So those are the success stories. So this is generally about AI, machine learning, neural networks, deep learning, and I talk about generative AI in a different slide. Yeah, any questions about this? Okay.
Please.
Yeah, please.
Yeah. What is the Amazon personalized? That means that it's
Yes, that's a good thing. So now assume that on Amazon you buy a book, like let's say you buy a book, computation, some computation book you buy, and then underneath they will say the users who bought the book that you bought also like something, right? So that means these things that they offer are personalized to you. Yeah. So those kind of things.
okay. So
I think
thank you.
that, I think that's the thing. So maybe there's more to that that I do not know. Yes. Okay. So in the applications of this AI has many areas. One area, some areas I will describe. The one of the most powerful areas is computer vision. And in computer vision, examples are Tesla's self-driving car and Avatar 2 production. Mm, these are two examples. Of many more examples are there, as you know. So maybe it is good for you to see. I will not show that video now. Avatar 2, making of Avatar 2, how that movie was made. Perhaps you can have a brief look at it, and you will see how cameras are facing the actors and how dots are there on the actors' faces and how they made the computer vision, computer graphics characters animated using those information. The main technologies that they use are convolutional neural networks and transformers, defect detection, volume applications, visual reality displaying, self-driving. These are all practical example use cases. And then the other important thing that you more regularly use is the natural language processing. Google search, Google's now Gemini, not Bard, right? I have to change this line. OpenAI is ChatGPT, Meta's Llama, now Llama 4 is available. Those are all large language models, and they predominantly use transformers and public chatbots, negotiators. All these are the example use cases. And in data analytics also, you know these Amazon's product recommendation system, YouTube's video recommendation system. That means if you watch one video, the next video that you watch will also be similar and interesting to you. So those recommendation systems have been coded using these techniques of data analytics. Quantitative financial models of hedge fund. For sometimes you can understand how the funds and other parameters in the world move, change, and then you can design algorithms to properly invest those funds. So machine learning, big data, natural language processing, cloud visualization. So all these things are used in this data analytics thing. So recommendation systems, customer profiling, business analytics in Netflix and Amazon are some examples of those. Yeah. Okay. So that's about major application areas of AI. Now in this area, there are different paradigms of learning: supervised learning, self-supervised learning, and reinforcement learning. These three we will study. There are many other things like weekly supervised learning, this, that, and so on. But these three things we'll briefly study. In supervised learning, we learn from labeled examples, like a student studying with answers provided. Needs pre-labeled data like flashcards. Okay, this one. Now let's take an example. Assume that you want to train a system to recognize the pictures of fruits. For example, I can give an apple. Of course, I know the label is apple. I can give banana. Of course, I know the label is banana because this is a label data set. So images and the true labels are available in this case, right? So this supervised learning is there. So when I give a banana, if it predicts banana, it's good. But if it predicts an apple, then there's a problem, right? So then it is not matching. So when it is not matching, it is a loss. And then you change the parameters of the supervised learner so that it improves its predictions. So this is the training time. Then there's a testing time. During the testing time, you don't have the label, of course. You give a fruit, and then the network's task is to say that it's a strawberry. So this is a supervised learning platform. In summary, in supervised learning, the training data has the images and the labels. That means the data and the ground truth labels are there in the supervised learning platform. This is the easiest, and this is how people started learning networks those days. Okay, then after that came the self-supervised learning. In this one, training or unlabeled data by feeding its own supervisory signal. This is very, very important. Its own supervisory signal. This is not unsupervised learning, self-supervised. So discovering patterns by itself. Two common approaches are there. One is reconstruction-based learning. One is contrastive-based learning. We also have worked on contrastive-based learning. So I will talk about, when I talk about conferences, I will briefly talk about the papers that we have also. I will show you an example for this. Now think about this example here. Now we have images of apples and so on. So I have those images. So there is no problem. I have the full image. I don't need a label for that, but I have the image. So what I do is, like a vicious man, I cut parts of that image off. You can see here, some parts have been cut off. We call it masking. Some parts have been masked. So task of the network that we have, and this we call the network, is to, although I give the masked one, its task is to predict the full one. Fill in the blank, fill in the masked parts and predict the full one. If they match, that's good. If they don't match, so if the completion is like this, is wrong, obviously, right? But I have the original image. Remember, it's not a label, but the original image I have. So I can compare with the original image. If the comparison is bad, it's bad. If comparison is good, if the exact image, it's good. So you can see now I have a supervisory signal to change the parameters of the network. Yeah. So this is a self-supervised paradigm. It's very powerful. So this is the training time. And then we have a phase called fine-tuning, where we use a set of labeled images, and we fine-tune that. And then finally, if we give a strawberry, it should say strawberry. So this encoder part is the only one that's there. So decoder part is gone now. So you can see I have shown you the representation that it makes. So this is the set of numbers that it uses to represent the strawberry. For a strawberry, it's a different set of numbers. For a banana, it will be a different set of numbers. And then using another little layer, we can predict that it is a strawberry. So this is the self-supervised learning paradigm. I will show you more examples later. And then reinforcement learning is
Excuse
a
me,
very
sir.
pop. Yes, please. Yes.
Sir, in the supervised learning, is it like, let's say we have a data set of images of fruits, so we input that to the model, and then model by itself do the masking, and then do the prediction, and then compare the original data set with the prediction. Is that it?
Uh, yes and no. So this is done in several phases, right? First of all, we take the images and we apply the masks. Apply the masks and we give it to the network to train the network. And then after that, we use a set of images that have the labels, a small set of images, and use it to fine tune the model. And then we test it during the testing time. Testing time is the production time. So these things happen in phases, different phases. Yes. I hope I understood the question properly. So if I didn't answer, please let me know.
Yes,
So
sir, clear.
yeah, thank you very much. Reinforcement learning is like training a child, right? For example, if you are training, okay, think about training a dog. Now we are training a dog to fetch. If you throw something, the dog has to bring that stick back to me. If it brings the stick, I will give it a biscuit. If it doesn't bring the stick, I will say bad dog. So like that, the dog receives the positive rewards and the negative rewards. And based on the rewards and penalties, the dog learns that it must bring the stick back if I throw a stick. So this is the reinforcement learning, but this thing about reinforcement is very, very powerful. All the large language models are also finally trained using reinforcement learning, but you need a lot of computational resources and other resources to do reinforcement learning. So we don't consider that in our class. Okay. Yes, those are the three machine learning paradigms I want to discuss. There are other paradigms, but these are three important ones. Okay. So now let's look at the perceptron. So I promised you that I will talk about the perceptron. So this one is the simplest sort of neural network, and this was discovered in 1958. So by U.S. Navy team called Dr. Rosenblatt's team. So here, now think about an input image. Now that input image has D numbers. D numbers. So this is an image. Assume that we have so-called pixels, right? You know that images are represented using pixels. Assume that altogether there are d pixels in them. We take each of these numbers and multiply by a so-called weight. This weight, those are the parameters of the network that we have to learn. So these are the network parameters. So now when you multiply, you have W times X. So all the W's I represent using one W and all the X's I represent using one X. So this is a vector, and in this case, this is also a vector. And then I add some so-called bias. So this is the equation of a line, right? You can understand this like y equals mx plus c, right? Y equals mx plus c. It's like the equation of mx plus c, very simple. Equation of a line. So it's exactly the same thing that you do, of course, but there is no just one x. There are many x's, but it is a linear equation, linear representation. Then we get the sign of that. If the sign is positive, we call it dog. If the sign is negative, we can call it the cat in a binary classification setup. So this is the perceptron. So when this perceptron came, people are very much excited. But I will show you that news article. Mm. This is that article. Uh, I don't know. Someone has posted that. I should have a copy of that article. Right? Yeah, this is that article. So there you can see new Navy device learns by doing. Yeah. I think I copy it and put it in the slide, then do some highlighting. highlight. Okay, the embryo, they call it the embryo, the weather bureau computer learned to differentiate between right and left after 50 elements of Navy's demonstration of newsmen. The service said it would use this principle to build the first of its perceptron thinking machines that will enable to read and write. And it is expected to be finished in about a year at a cost of about $100,000. Yeah. The Navy said that the perceptron would be the first non-living mechanism capable of receiving and recognizing and identifying its surrounding without any human training or control, and so on, right? So all these things they claimed, but you know that to to read and write, that means ChatGPT like read and write, it took 70 years and billions of dollars, but now it has been achieved by people. So this is that thing, perceptron. But people found that there is a big problem in that. That problem is this. So this one is actually a line, equation of a line. This one is an equation of a line. So therefore, if you want to separate data, assume that you have only two numbers in the image for the time being, okay, two-dimensional data. This is what I can show on a computer screen. You want to separate between squares and circles, you can only separate that with a line. So it's a linear classifier. So people then realize, okay, it's a very bad thing. It just can do linear classification. So therefore, this killed the interest in neural networks, I think, this finding. But if you have this so-called, this is called a nonlinearity, this sign function, it's not linear as you can see, it's not a line. So if you have these nonlinearities and more than one layer, then you can simulate an nonlinear function. You can see this is not a line anymore, right? So therefore, it can nicely separate red circles from orange squares and learn nonlinear functions provided each perceptron has a differentiable nonlinearity. So hopefully we'll be able to learn these things in this class, and this is the start of these neural network things. Yeah. So when we look at a linear classifier with a very basic simple example, this is from this very famous tutorial by Stanford people. Yeah. Any questions up to now? Okay, let me continue. Okay, now you have to carefully see what I'm saying about this. Okay, uh, this one, um, it has a cat image, a very ugly cat, a very ugly cat. I don't know why they selected this very ugly cat. That cat, of course, we know that this cat image has so many numbers, okay? But assume that it is represented using just four numbers, 56, 231, 24, and 2, just four numbers. And then there are three rows of numbers. This is the row for the cat, this is the row for the dog, and this is the row for the sheep. So to get the cat score, what you do is you take this number and multiply with this 56. You take this minus 0.5 and multiply with 231. Take 0.1 and multiply that with 24, and take 2 and multiply that with 2, and let's add this bias and this b, and then you get minus 96.8. Yeah. Then do the same thing with the second row, that's the dog row, you get 437.9. And you do the same thing with the ship score, you get 61.95. So higher is the better thing, okay? So right now, the network thinks that it is a cat, dog, or a ship. What do you say? So maybe please answer that question so that I know that you are able to understand that. As of now, the network says cat, dog, or S. What's the answer? Cat, dog, or S? Yeah, no. Yes, a lot of people are saying dog is, that is correct. Thank you for your answers. It says dog. Why the dog score is high? So why is it making the wrong prediction? It is making the wrong prediction because we did not still train this. So when the network predicts the cat, and but actually when predicts dog, it's a cat. So we have to make that correction. We have to create a loss function and then minimize that loss function using some technique. And that technique is actually back propagation. We will learn about that later. If you do that, if you do the backpropagation and learn this linear classifier, finally, if you take this row, for example, okay, this row right now has 4 numbers, but I'm saying that it has many numbers, okay? This is just a toy example, and arrange it like an image. Arrange it like an image, and it will start looking like a cat. So these are some examples of actually dog row, frog row, horse row, car row. So you can see the car row looks like a car, right? The horse row looks like a horse looking this way and looking that way. What's the reason for that? In the actual training examples, there were horses looking left and horses looking right. So this is how a linear classifier can be learned. And after learning the linear classifier, your weight matrix rows look like actual image templates. And this was, surprising for people, and people were very happy to observe that. Yeah, this is a linear classifier. Hopefully when we start doing the neural networks, we'll be able to train this with a few lines of code and see that this actually happens. Yeah, okay. So that's the linear classifier. You can see we just have W times X plus B. That's the equation of a line. Line in 1D, and plane in 2D, and so on, hyperplane and so on. This is so the next thing is the convolutional neural network. This is how the convolutional neural networks work. You can go to that website and see for yourself, but I will not explain too much. But uh, you can see, I will run the animation a little, and you can see how the convolutional neural networks activate things. So here, one thing you can see is when the person clicks ladybug and so on, it activates a certain number of paths, and then the appropriate thing is you can see it's highlighted, right? Bell pepper or something. Yeah, and so on. They're highlighted. So intermediate weights and so on, they get updated. Yeah. So please watch this, and you'll be able to see how the inside weights also get updated. But I will not display the whole thing because it will take quite a lot of time to get this. So you can see internal weights and so on, how they are arranged is shown in this animation. Okay, that's convolutional neural networks. We will study convolutional neural networks in detail in the class. Okay, yeah. Then how the transformers, the main operation in the transformer. This is not exactly how transformers work, but the main operation in the transformers is called attention. So take two sentences, for example. The animal didn't cross the street because it was too tired. I'm asking you, what does it refer to? Of course, because we are human beings, we know that this if it refers to the animal. So you can see the attention learned by the network for the animal is stronger. Others are not that strong, right? Others do not have attention at all. But if you take this sentence, the animal didn't cross the street because it was too wide, you know that it refers to the word, it refers to the street. So, depending on the context, the words attended to by each word is different. So, this is able to be captured by the attention mechanism in the transformers, and the transformers have the power to stack many transformer layers on top of each other because their input size and the output size are the same. So this is the paradigm that is driving all the ChatGPT like advancements and all the computer vision advancements now, the transformers in general. Yeah. Okay. So I propose to talk about the generative model. So we will briefly talk about generative models. I think This one is new information for you. I think you did not think about generative models like this yet, but this is the proper definition. Okay, think about this now. Think about this normal curve. Yeah, think about this as the Z score. Z score. So if you take the students who have Z score 0 are so many. The density here is very, very, very high. So that is represented here. Density is very high. Yeah. And the students who have slightly high Z score also generally they are slightly low one also there. So represented by generally higher density. But students have these kind of Z scores like maybe 3, Z score 3 are very small in number, very small in number. And that kind of students, as you know, in my department, electronics department, we have the island based in our department A level. So I'm very happy about that. So, for example, we had Osha the Jaipriya, his score is 3.2. Tarusha Fonseca, his score is 3.199. So these are extremely high score students, highly intelligent. And then there are people who are extremely poor in early class also. So you can, I hope you understand what this normal curve represents. It represents the density of people right now, as I described, based on this score. So now, what are the chances of sampling something from this? If I sample, okay, you have all the students, I take all the A-level students and put them in a room, and I take a student out. What are the chances of taking a student with Z score 0? Very high, right? That's very high, very high. If I sample from distribution, mostly I will get zeros. Maybe I will get very close by values mostly. For example, I will get a Z score equals 0.3. That's highly probable. But getting a Z score, getting a student with Z score 3 is highly improbable. So what that means is, if I can have the probability density function of data, I can sample and I will get students who look like generally those students. Yeah. Okay, this is only in 1D. If you go to 2D, it will look like that. So the most high density is at the center. This is the 2D normal curve. When you go to the edges, the density is very low. Density is very low. Density is very low, and so on. Density is very low. So if you sample something, it is highly probable I sample a highly probable number. Maybe you get 0.3 and 0.4, something like that. So I hope you understand what a probability density function is, and you can sample from that. So highly probable samples will come out. Now let's move to from 1D to 2D to the image dimension. Now consider small image of 32 by 32 color image. So this will have actually 32 by 32 is the resolution, and you have 3 for color, 3072 numbers. 3 times 32 times 32, it will have 3072 numbers. That high dimensional, very high dimensional. And then assume that I have the probability density function of all color 32 by 32 images. Somehow I built it. Somehow I built it. If I do that, and if I have the probability, now I can show it using an picture like that. Okay, so I just showed the some probability density function domain like that. And if I sample from that domain, from highly probable ones, I'll get images. If I sample from highly probable areas, yeah, I'll get images that actually look like actual images. But if I sample from outside, I will get noise. So you can see this is how image generation happens. This is how language generation generally happens. But there are more details we have to study. We have to study the individual models. So they sort of represent the probability density function. So if you take language models like, for example, ChatGPT, BERT, and so on, given a certain set of words, for example, I am, if I have words like I am, given these two words, next word, probability it predicts. So it doesn't build the probability density function per se, but it knows how to predict a highly probable one. Yeah, highly probable one you can predict. So this is generative learning. So generative models learn the underlying distribution of data. Once learned, they can generate new data samples that resemble the training data. This is generative modeling. Yeah. Any questions about generative models? Yeah. Okay. Yeah, so if you take generative AI, there are so many applications, as you know, text generation, generative AI models like generative pre-trained transformers, that means GPTs by OpenAI, generate human-like knowledge, so chatbots, ChatGPT, Gemini are examples. Image and video generation, stable diffusion generates realistic images, and visual content based on textual descriptions. It's good for advertisement and entertainment. So if you go to Midjourney, you can generate these kind of images. Data augmentation, generative AI can generate additional data samples to augment data sets for training machine learning models. So training models with less data. So that's an example. Music composition, this, that, and so on. So there are many generative tasks, as you know. I think you know these better than I do. Okay, so let's briefly see how the BERT model works. To train this generative model, this is the 2019 work by Google. So one of the foundations of understanding how to do text generators, large language models. So their system was very simple. They had the original sentences. Let's stick to improve in this. I don't know what that means. So what they do is they mask the word. Right? Mask the word. This is like fill in the blanks, right? So for example, in school, you are given sentence I blank ice cream. In school. Yeah. Then you ask to fill in the blanks. You say I like ice creams, right? So from the context, you can fill in the mask because you have the language model in your mind. So we want this neural network called BERT also to actually provide, predict the word that should have been there in the mask location. So they randomly mask 15 tokens. We call them tokens. You can think they are slightly smaller than words. And now for that position 5, it predicts probabilities. So for the first word in English, aardvark, probability is 0.1. For the last word in English, I think there are about 30,000 words like that in English. For each of them, they predict a probability. So hopefully the highest probability is for this word. So that will be it. So because we know the original word that should have been there because we have the original sentence. Now if it makes a mistake, we can correct the network. So you can see a training signal can be derived based on this masked language model. Masked language model. So you can see it's a very powerful paradigm. After you learn the language model, then you fine tune that for question answering, next name, these kind of things. They can fine tune that. These are called masked language models. This is the first masked language model, BERT. Okay, so now that is in the language. So I'll give you an exercise for computer vision. So what is hidden here? So can someone type the answer to this? What is hidden in this? If one person types, I'll be happy. In this image, what do you see? And it's very simple. Yeah, so banana. Thank you so very much for typing that. It is a banana. True. So yeah, it is like this one. Yeah, I'll tell you what it is. It's a polar bear. Okay, it's a polar bear. Yeah. Thank you very much. Okay. Now the difficulty level increases. What are behind this? You don't have to type. You can think. What is there behind each of these images? You can think. You can move back and forth and see whether you can guess that. Third one, a dog. I think that's correct. Yeah, these are actually images from the paper that describe the so-called mask image model, mask image model. It's a 2022 paper by Simon here and others, 2022 paper. Oh, clock bites dog bird. Oh my goodness, I don't know how you do that, but that's the correct answer. Final one is actually a lampshade. These are the ones. Yeah, okay, good. So see, you have the original images, you mask out 80% of the patches or something, and then ask the network to predict those patches. If they properly predict, it's good. If they do not properly predict, you derive the loss signal by this, and then you train the network. So this is called MIM, or the mask image model, similar to the MLM, the mask language model. So you can see these are self-supervised models, as we discussed at the very beginning of the class. Self-supervised ways of doing, and they are very, very powerful. And that's how things are done currently. Okay, so this is exactly the picture from that paper that I described. It's from CVPR, the topmost conference of all conferences now. It's by Kaiming and others. Mask encoders are scalable vision learners. So you can see this is the main diagram of the paper. So they take this flamingo image, mask out some patches, okay, give to the so-called encoder these unmasked patches, and then it encodes, and then to the decoder, these unmasked patches encodings, okay. These are the numbers that I talked about. These are the representations. Those and some representation from the mask, and it will ask it to provide the full complete image. If the full complete image is provided without any problem, that's good. If it doesn't provide, that's a loss. And so with this loss, we train the whole network, adjust the parameters of the network. Yeah, this is the so-called self-supervised pre-training of the mask autoencoder. Yeah. Okay. So yes, please.
Yeah, so that encoder and decoder, they have to process, no? That means
Yes.
mask.
Yes.
So is there a mathematical calculation happen in that?
Yeah, it is a mathematical calculation, but it's of course done in Python code, right?
Python, from the
code.
backend, yeah.
Yeah, it happens in the graphics processing GPUs.
Okay.
The GPU. So these we will understand what those kind of computations can be.
It
Yes.
by only handles by Python. That means
Python means you code it in Python, but underneath everything is computed in C++, right? That means we use a framework like PyTorch or something to code in Python, but computations actually are handled in C++ and low level, slightly low level languages. Yeah. So
yeah,
they are mathematical, but actually they are computational models. You cannot represent that using an equation.
okay.
Yeah.
Thank
So
you.
then, thank you. Then one question is there: what is meant by a mask? Mask means you see that part of the image was there, right? For example, here, and you cut it off. You cut it off. That's what masking means. Okay. So then,
Excuse me, sir.
yes, yes.
So now we discuss about this probability density function, the attention, right? Attention and this masking, right? So
Yes.
all these are combined to create the LLM, is it? Is it something like that? How should we see the big picture?
That's a good question. So if you take the LLMs, there are no images are involved. No. LLMs use a mass language model, right?
Right.
Sentences they scrape sentences from the internet, and some words are masked, and then they are fed to their networks, and then they predict, and then when an error is made, they will correct. Correct means when the correct word is there, there's some loss. When the wrong word is there, there's some loss. Based on that loss, they adjust the parameters in the network. So by that, they will not actually construct the probability density function, but they will be able to produce the probabilities for all English words for the next word. So in this one, for the missing word is this one. They are producing all the probabilities of all the words in English. There are about 30,000 words. They produce 30,000 probabilities. So hopefully the highest one is the correct one.
So to generate the probabilities, what do they use? Is it like based on the attention of a given set of corpus, something like that, or how?
That's a good question. So first I'll answer the first question. So to find the probabilities, now we know the correct word. We know the correct word that must be there, right? That is the improvisation. So therefore, my correct signal is zero probability for this word, zero probability this for this word, probability one for this word, zero probability for this word, zero probability for this word, and so on. So I know the correct one, right? This is the true one. This is the predicted one. So I find an error between these two. So I will find, I will just say, I'll put only minus sign. No, actually, it's not the minus sign. There's some other error function finding between these two. So if this is not giving the highest probability, that's a problem. If this is giving the highest probability, it's okay, it's matching. So whether this ground truth and the probabilities match, we check. So by if the network makes a mistake by adjusting the parameters, we will force it to give this correct set of probabilities. That's how the probabilities are learned. But then, what is the contents of this network? Inside that, what is the computational mechanism? The previous person also asked that. That computational mechanism contains attention. Contains attention. Because attention is very important, because the probability of a word being there depends on the words that are around it, right? So this word depends on eye and ice cream. Right? That's why this attention thing is important. But the way of actually computing that, I cannot explain it. So those are not even a part of this course, because this is not a deep learning only course. This is a computer vision course. Fully deep learning course, in a fully deep learning course, I would have been able to explain those things. Yeah. But of course, if
Thank
you
you,
have
sir.
time, we can explain how a computation and how they actually done. That means code a transform model by hand. Yes. So I hope that you got some picture about that.
Yeah, thank you, sir.
Yes. So one thing is like, based on your question, assume that due to some reason now, this is providing a set of probabilities now, and then we pick a word that is of high probability, not the highest, high probability. Yeah? If you just pick the highest probability, you get the same set of output. So we pick a probability with high probability, a word with high probability. So due to some reason, in that random sampling, if a low probability word comes out, yeah. So instead of improvisation, a word like fairy comes out. Now that will affect the next word also, because in the GPT models or language generating models, these are next word generators, autoregressive next word generators. So it eats the word it generated and produces the next word. Okay, it takes this next word and eats it and produces the next word. So if you make a mistake, rather than saying improvisation, you say fairy, then the network can go in a very different path. So this is called hallucination. So I think it's a simple explanation of hallucination. I think it's much more complicated in the current networks than what I said. This is a BERT model, it's a master language model. Then other language models are also there. So GPTs are, I think, different. But these kind of things can happen because of this probabilistic nature, hallucination, and all these things. We can explain if you understand how they work. So yeah, so thank you for those questions. And also, this is just a simple introduction of 1.5 hours or so. So if you will not be able to fully understand how they work with this, because I'm not teaching actually. I'm just showing you what is available and giving some understanding for you at the surface level only. Okay, this I think you understand. So this is the mask image paradigm for self-supervised learning. This is another self-supervised learning paradigm. Think about this one. In this one, this is called contrastive learning. You contrast. When your kids also assume that you want to train the kids, very small ones. Okay, they are in Montessori, so color. So you ask the kid, you show two objects of red, one object's blue, and ask it to put the blue ones together, similar ones together, and dissimilar ones away. So with that, the kid will learn the concept of blue. Otherwise, it's very difficult to teach him the concept of blue. what is that? Like, I mean, blue, does the blue mean kite? Does the blue mean a ball? I mean, it's very difficult, right? So, but if you give two pictures of the same color, two objects of the same color, an object of different color, you can ask the kid to contrast. By contrasting, it can learn. So, how does the contrastive learning work in images? So, you take an image of a golden retriever and a change image of the golden retriever. It's the same golden retriever, and an image of a beagle. I mean, these are all these both these types of animals are very good animals. Huh? Golden retrievers and beagles, they are all of a good demeanor, and we encode it. And this is the representation that I talked about. This representation should look like this. The two images of the golden retriever should be close by, and the image representation of the beagle should be far away. So bring together the representation of similar examples, push apart representation of the differing examples. This is called contrastive learning. So this also can provide a very powerful signal for us to do self-supervised learning. So what are the two techniques people use for self-supervised learning? Masking and contrastive learning. Okay. This encodes how to represent a dog. So that's why these kind of things are called representation learning. Okay, then someone asked about books. These are the books. The first book, Gonzalez Wood and Woods, Digital Image Processing. It's a very good book if you want to learn image processing. And then you have Forsyth and Pons, Computer Vision, a modern approach. It's a good book for both, mainly for computer vision. Then Richard Selinsky's Computer Vision Algorithms and Applications. It's available online. There's an advanced book. It talks about current research also up to some extent. And then Milan Sonka book. It contains both image processing and machine vision. There's another book which I did not put. I should have put it there. It's a new book. I have a copy of that now. It's called Thoralba's Computer Vision book. This book. This book. I should have put that here. That's a very good book for computer vision. Okay, all these are very nice people. Okay, they have made their online copies freely available. So if you don't have to buy the book, you can read the book. I'll type that out here. Fine. These are professors in different universities. Okay, those are the books. But if you want to study machine learning only, this is one of the best books I have seen. I can see that. Probabilistic Machine Learning by Kevin Murphy, Algorithms, Book 1. Probabilistic Machine Learning, An Introduction by Kevin Murphy. That one. If you can see that. And then, if you want the statistical perspective, this one is a good book. It's called An Introduction to Statistical Learning. It's the simpler version of the book by the original authors. It's authored by Garrett James and others. So these for machine learning. Then conferences and journals in our area. So CVPR is the best conference of all forms of conferences. I'll show them in Google Scholar. So we have to go to Google Metrics. Google Metrics, and then of course CVPR is the second to Nature. It's a top conference of all forms of conferences. Then you go to Engineering and Computer Science, and then you go to Computer Vision and Pattern Recognition. So you can see CVPR, Computer Vision, European Conference of Computer Vision. It's called ECCV, International Conference of Computer Vision. This is TPAM. It's a journal. It's the highest ranked journal of all of engineering, highest ranked journal of computer science also. IEEE Transfer Image Processing, Winter Conference of Computer Vision, Medical Image Analysis, Pattern Recognition. CVPR workshops, International Journal of Computer Vision, and so on, and ICCV workshops, British Machine Vision Conference, and so on, Asian Conference of Computer Vision, and so on. So I'm happy to say that our group has 2 CVPR papers. We have many WCV, several WCV papers. In application computer vision, many WCV papers. We have one ICCV workshop paper. We have a couple of British Machine Vision Conference papers. We have ACCV paper. And this is the computer vision and pattern recognition. If you go to AI, artificial intelligence, neural information processing systems is the topmost conference. We don't have a paper there. Last year we got a paper in ICLR, International Conference on Learning Representations. I have, for my PhD work, I have paper here, Transaction System and Cybernetics. So ours is the only group that has papers in these areas. Heradinia has an ICLR paper. So yeah, this is it's very important to only be guided by topmost publications, because other people do not understand the area, the reviewers, so therefore they make mistakes in accepting papers. So in radiology, like if you want to look at medical image processing, and then you have to go to healthcare and medical sciences. There you have radiology and medical imaging. There you have top conference is this one, medical image computing and computer assisted intervention. It's called Mackay. We have one Mackay paper. So these are the top forums. So I'm happy to say that I am a reviewer for all these conferences. I'm a reviewer. I have been a reviewer for this one and this one and so on. So if you want knowledge, please go to these forums and gain knowledge. In robotics, if you are interested in robotics, the two top conferences are ICRA, IROS, and CURL, I think. Okay. So, some tips for successful completion of this course. Your mindset should be: I want to solve this vision problem. What are the tools available? How have others solved it? Should I go about solving it? Not just an exam. So I don't teach for exams. So we want to do something with this. So please attend every lecture, because a lot of information will be there. And if you do not, of course, I will make the videos available. But if you do not listen to those by investing those 2 or 3 hours, then it will be a lot of videos for you to watch. I think it will be hard. So please attend lectures, go through the material the night before, and engage in a good discussion in the class. So today you did that. I'm very happy for engaging in a discussion, and implement at least one algorithm discussed in class before the next class. Do some little bit of Python coding, then it will open up many things to you, and you will understand the classes. So we use Python and OpenCV and PyTorch in this class. So computer vision software companies are these, but we don't need them, but I'm just mentioning them. Camera companies and some camera catalogs are here. So it's a little bit of work that we have done at our department. All these things are published. So this is by Osha the Jasing and others. He was the island-based officer. So we have a traffic sign and traffic light detection in embedded systems. So we have the database also freely made available. So all Sri Lankan traffic signals and traffic signs. This is the drivable area detection work by Ocean and others for all for many Sri Lankan roads. This is also quite hard for Sri Lankan roads, although it can be done for their roads. So this is also published. And then this work was done sometime ago, 2020. You can see a little bit some time ago. This is a collaborative robotics project. You have a camera at the top. It sees the arena, and then there are 3 robots. They work collaboratively using reinforcement learning to build the building that is defined by the plan that we visit. It's an advanced project. This one is actually a recent work. This is the Mackay work that I mentioned. So we get 3 ultrasound images of the liver. There are specific ways to obtain that. These images you cannot even identify where the liver is, right? I am sure. And then we segment it out, segment the liver out, using a network called TransUnited. It's not our contribution. And then we have the masks, and then we have a so-called parameter regression network, and we get the parameters. And we have a statistical shape model of the liver learned from CT images. CT images are much clearer compared to ultrasound images. And then with that, we can obtain a 3D reconstruction of the liver of that patient. So it's like magic. You can see the radiologists are also involved. So if I have forgotten to include the most important name here, bad me. So I will do that immediately. Professor Udari Liyavige. So these are radiologists in University of Colombo. Professor Udari Dr. San Guruge, Dr. Jeevan Udupil is in Peradeniya. These are different. Professor Saroj, when you heard his name also. So this is we did that in collaboration with radiologists and us. This one. So Zone 24/7. This company was involved. Dr. Gerard Fernando is from that company, and I think they are trying to commercialize this. Yeah. Okay. Then the little bit of quizzes. So we'll these are the quizzes that I have given. Very simple questions. So we'll do 1 or 2, and then we will take a very short break, 1 or 2 minutes. During that time, I'll create the WhatsApp group for you. And then we'll see how to install Python and so on to get some little bit of vision work done. Yeah, okay, let's answer these questions. Question number 1. What is the primary difference between image processing and computer vision? Image processing enhances images, computer vision interprets them. Image processing is used only in photography, computer vision is used in robotics. Computer vision converts analog signals digital, image processing doesn't. Image processing needs machine learning, computer vision doesn't. There is no difference. So answer is the correct one. Right? So remember, image processing enhances images. Input is an image, output is an image. In computer vision, it interprets them with a decision. That's the answer to that question. Question number 2. What of the following is an example of computer vision? Histogram equalization, Gaussian plus semantic segmentation, image processing, image sharpening, padding. So semantic segmentation is a computer vision task. I showed that in the mask. Mask RCN is actually an instance segmentation one. So semantic segmentation is a computer vision task. What is the goal of early vision in computer vision pipeline? Compressing a video, extracting high-level semantic from images, creating 3D point clouds, extracting lower features, edges, and textures. So D is the correct answer. Yeah. I hope that these things are clear to you. Okay. If you have a question, please ask. Which of the following best describe the structure of this course? Sir, could you also please give a brief description about basic things and image, including representation, dimension? Yeah. Those things, image dimensions, those things we will start doing from next week. But today we will start that. Yeah, just after this. At 12:30 we are finishing. Which of the following best describes the structure of this course? It is focused on entirely deep learning for image generation. That's not correct. It includes image processing, computer vision, and recent vision model. That's correct. I hope it is correct. It is limited to classical image processing. No, it covers only industrial and no, it hardware. No. Which of the following is recommended to succeed in the course? Memorize all the equations before exam. Implement at least one algorithm before next class. Yes. Avoid reading papers. Wrong. Focus only on the coding exam. Wrong. Use mathematics. What is the advantage using PyTorch in this course? It requires no coding knowledge. It is optimized only for image compression. It supports dynamic computation graphs, and this I did not describe, but this is the answer for that question. It describes dynamic computation graphs and deep learning libraries. It is a hardware simulation tool. It only works for C++. Question number 7. Which of the following is a real-world application of computer vision? Applying median filter into smoothness image, detecting faces in surveillance footage. That's the real-world application, right? Printing high-resolution images. No. Converting RGB to grayscale, saving images. Because this is the only computer vision application, right? Detecting faces and so on. What is an example of a generative model in vision? Histogram matching, optical flow estimation, diffusion model. Diffusion models are generative models. stable edge detection by linear interpolation. So I talked about the stable diffusion, right? I hope you remember. Which of the following is a typical use case of segmentation in vision systems, enhancing the brightness of an image, estimating the motion of objects, detecting boundaries between different regions of an image, converting images to JPG, add color to grayscale image. Detecting boundaries between different regions of an image is segmentation. Question number 10, last one. What is meant by self-supervised pre-training in deep learning of a vision? Training a model on random images from the internet. Learning from labeled dataset with minimal supervision. Supervised learning using multiple GPUs. Using reinforcement learning to train vision model. Learning meaningful representation of unlabeled data. That's the one. So those are the answers for those questions. So now that the first part is over. Now I will describe a few things about getting the software platform ready. I will show a video and you can watch the video by yourself. And then we'll do a little bit of image opening and display during the time left. But I will give you a 5 minute break now. So until I come back, you can have something to drink or something. I'll create the WhatsApp group.
Excuse me, sir.
Yes.
So the quiz time is around 1:30. So is that a time?
You can do it, right?
Yeah, 11:30 to 1:30.
Yes. Is it? It's possible, right? Even now you can. I mean, you know the answers now.
Yeah.
If you need more
So,
time, of course, I can give. Yeah.
okay.
Okay, I shared the WhatsApp group, so please join so that you can ask any question after the class, or we can have announcements done. So yes. Okay, now I will show you how the software system should be set up, but I will not fully describe that because I have created a video for that. That video link also I will show. So I have this YouTube video. Yes. This one. So you can see this video. Package. That one I will send through Zoom chat. So after a lot of people join, I will put that in the WhatsApp group also. So it's a like 12-minute video. So if you watch this, you will understand how to download these things. So that we can use install notebooks in Visual Studio Code. I talk about how to install Python, how to install all, we have Jupyter, and how to use VS Code for that. So-called I trust. Yes. Yeah. Things are all in the now. So most of you may know that a 3x3 array. Then I printed that array. Also, I have included that in the Moodle page also. In the Moodle page, I have linked that. Oh. Setting up Python, Jupyter, and VS Code. So I have linked that also. Also, if you do not know Python, you have to go through this tutorial. Even if you know Python, I think the NumPy knowledge may be very useful. So therefore, please go through that, especially the thing called slicing is important to know. So it will take 1 hour for you to go through this. So therefore, I kindly request you to go through that also. I will link that in Moodle Python NumPy tutorial. Stanford. So remember, without Python and NumPy, we cannot do an image processing course. Okay, computer vision course. So therefore, it is a must for you to learn these things and start coding. But to do some coding, you don't need immediately Visual Studio Code and so on. So I code here like this. You can I will show you some picture. So I code in Visual Studio Code. So I have installed OpenCV, which is what we will use in this course, and PyTorch. So you have to get this environment working. But you can use Colab for this initially. So you type collaboratory, Colab in your browser, and you have to have a Google account for that. Then you click that, and it will ask you to create a new notebook or use an existing notebook. So I say new notebook. So to Colab will create a notebook for you. Yeah. Now, what I'm going to do is I'm going to create a black and white grayscale image and display that for you. So for that, I will use NumPy. So import NumPy as NP. Import NumPy as NP. Right. Okay. That's it. And then image equals NumPy NP dot zeros. So I have to give a size for that image. Right.
Marvin Rodrigo.
So I have to give a size to that. I will put the size as 6 pixels tall, 8 pixels wide. And I have to give the data type. D type equals np dot uint 8, not unit, uint, unsigned integers of 8 bits, uint 8. Now this array is ready. So you can just click this button and run it and see whether that is working. Okay, it works. Now not a problem. So what I'm going to do is now in this image I'm going to set the pixel 2, 3 as the brightest. The brightest is 255. Remember, in the unsigned integers of 8 bits, you have 8 bits. That means the smallest number is 0, 0, 0, 0, 0, 0, 0, 0. That's the smallest number, all 8 zeros. The largest number is 1, 1, 1, 1, 1, 1, 1, all ones, right? I mean, obviously, right? Smallest number, because you have only 8 bits to represent this. So this is in binary, of course. What is it equal to in decimals? This is 0 in decimals. This one is 255 in decimals. Yeah, I hope you can understand that. This represents 1, this represents 2, this represents 4, this represents 8, 16, and like that. When you add all of them, you get 255. So I set the maximum intensity there. Now I want to display that. So to display, I need so-called matplotlib. Import matplotlib.pyplot as premt. Yeah. So I imported that. Now I'm going to display that. plt.imshow. You can use the imshow command. So my image's name is im, and I had to use a color map for that. Cmap gray. Cmap equals gray. Cmap equals gray, and I had to give the minimum value and the maximum value of my numbers. Vmin is of course 0. Vmax is of course 255, and then I can show that plot. plt dot plt dot show. Yeah. Okay. So now if I run this, I'll be able to hopefully see an image. So you can see 0, 1, 2 second row and 0, 1, 2, 3 third column is white. That's 1 pixel. So this pixel, this image is a 6 times 8 image, right? That is altogether you have 48 pixels. Very small image. New cameras can get thousands of, like 3000 by 4000 by 3000. That's like that, right? But this is a very small image. So that's how you create an image. So I think you understand what uint 8 is. That's the grayscale image, black and white image. Yeah. So in this one, you have something called markdown also. That means you can include text also. So I can write here. I haven't anything went wrong. I can double click and enter. a 6 times 8 grayscale image. It's a creating, right? Creating a 6 times 8 grayscale image. Okay, so that's what we did here. Maybe add some color to that or something. Yeah. No, now you want to create a 6 by 8 gray color image, right? So the grayscale image, so I'll put a color, color image. So I'll put another mark down here. When you hover your mouse here, you'll be able to do that. So this same thing you can do in Visual Studio Code, but it will work on your machine. Color image. So for that, I will write the code block here. Of course, I had to import these two. Then my image will be so it prompted and gave me this color image. So you can see, rather than writing 6 and 8, only I had put 3 because there are 3 colors for a color image. So now I will say im 2, 3. I want to set something, some pink or something. So I have to put 3 values now. So I will put RGB, so red about 200 red, a little bit of green, G, okay, a little bit of RGB, blue, little bit of blue also, 20 something. Okay, and then it's the same thing to display, so I will display it like that. Yeah. Now color map is not gray, and these are not required now. Color map is not gray. Okay. I hope it will work. Yeah, so you can see I have some crimson color. So to get pink, I think a little bit of blue is required, right? Yeah, pink. So to be respectful of all the very important ladies in the class, I put pink here. So think about ladies is they will start liking different colors in their life. They will say I like white, or I like blue. Finally, they all zero in on pink. They all like pink now. I think all of you in the class like pink. So yeah, these are the two things. So maybe you can make a screenshot or you do these things. So some person asked how the resolution and so on. This exactly this is the resolution of this image. 6 by 8 is the resolution of this image. This is 6 by 8 grayscale image. Grayscale. 6 by 8 grayscale image. That one. This I think you don't need. You understand that. Grayscale image. For the color image, you just had one more number. So then you will ask me, how do I understand how to create these things? 6, 8, 3, you put 3 numbers. Why did you put parentheses? These are all there in the tutorial. So please do the Stanford, this tutorial by Stanford. So they will tell you how to create all these things under NumPy. Yeah, see, NumPy zeros. So all these things are there. So they are essential actually. So I'll let you code this. Actually, that's all I want to do for today's class. So you can see what we did today is understanding the whole landscape of AI and where computer vision fits there. So one of the main parts of AI is computer vision. There are two main parts, AI and natural language processing. Then we looked at some applications, and then we look at the different parts of computer vision, early, middle, early vision, and so on, fitting, and so on. We looked at, and then finally we come into the deep learning part. Then after we concluded that part, we did this small collab exercise to show you how two images can be created. That's the very start. From next time, I have uploaded the slides on the Moodle. If you like, you can go through the slides before the class. I think I would very much welcome. So we start the basic image processing operations, point operations, and so on. We will start creating images and so on. With this, we will start. So all the codes I will show you, and we'll be able to do, and you'll be able to happy if you code like this. So maybe you can think about this and do some more examples, and then you will be very happy. Any questions before we conclude the class? Okay then. So if you do not have any questions, you can log off. Thank you very much for coming. Please do the simple quiz. I think you already know the answers. And if you have any question, you can please stay in the class and ask. Have a pleasant the rest of the Sunday. Thank you very much.
Thank you, sir.
Thank you. Thank you.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you.
Thank you.
Hello, sir. Am I audible?
Yes. Yes. Yes.
Sir, will you be uploading lecture recordings to the module?
I'll be uploading, but the Moodle takes so Zoom takes some time to process, right?
Yes, sir. Yeah, yeah.
And I'll be traveling, so after that, maybe at night time, I'll be able to upload.
Okay, sir. Thank you so much.
Yes.